Welcome to transformation. So a transformation can be defined as a change of position, size, or shape of an object following the application of a geometrical operation. So this may be the translation, the reflection, the rotation, the enlargement, shear, stretch. Note, the object that results from a transformation is known as the image. Just a quick example, you as a human being, we can say you are an object. Then when you look on a mirror, that will be the image that will be formed on a mirror. Look at this example. The question reads, the diagram below shows two figures, P and Q, on the X or Y plane. Describe fully the single transformation that maps P onto Q. So P is the object, Q is the image. It means this Q came from P. This is what we mean by object image. Q came from P. P is the original figure. Q came from P. This P was transformed into Q. You see, this is the concept of transformation. In the next video, we'll be able to deal with such questions. For now, just know that the object will be transformed into something, and that thing will be called an image. Now, let us go in detail on each of these types of transformation. Remember, we had translation, reflection, rotation, enlargement, shear, stretch. So now let's look at translation. So translation, it involves moving in a fixed direction. The object can be pushed or can be pulled. The object can be pushed or pulled. So translation deals with the push and the pull of the of the object. We'll be able to look at examples on how to deal with such. So we have the formula that we use. The object plus the translation, which is T, gives you the image, which is I. So object is O plus T is translation is equal to image. So look at for examples for each of these types of transformation. 2. So for this formula, it means we'll be replacing for us to find the object. It means translation and image will be given, or we can find the image when object and translation are given. Look out for more videos on this. So reflection, it is another types of or category of transformation. So in a reflection, an object is reflected in a line called a mirror line. See? So here we're talking about the reflection. The object will be reflected from a point we call a mirror line to form an image. Anyway, so now, when the mirror line is on x is equal to 0, that is the y-axis. Look at this Cartesian plane. This one is your x is equal to 0, which is also lying on the y-axis. So what it means here is that this x is equal to 0 is the mirror line. So what will happen if the object is like this? like a triangle, just know that the image, so this one is the object, the image will be formed same distance from the mirror line. It will be formed the other way, facing this side. This could be the image. So mirror line will be in between. This is what it means. So you have to know that the matrix which is used is -1, 0, 0, 1. You'll be able to know how we are able to use these matrices for each mirror line. Next, when the mirror line is y is equal to 0, which is on the x-axis, in this case, y is equal to 0 is this line which is lying on the x is equal to 0. It means if the object is here, the same here to be reflected, you see that? So if this is the object, the image will be this side, same distance from the mirror line to the object, and from the mirror line to the image, same distance. So it will be reflected in this way. What happens when you get a mirror to see your face? You see, your forehead will be seen first on the mirror. Your forehead will be seen first on the mirror. Same. These are facing each other, showing you that this is a mirror line. So the matrix for this type of a mirror line, we have 1, 0, 0, -1. Have you seen the difference? The -1 which was here is now down, representing to say it is now the mirror line is on the y is equal to 0. Next, when the mirror line is y is equal to x, how is the mirror line formed, or how do you draw it? It is in this way. It has to be in this way. So it means if the object is this side, the image will be formed the other side. As simple as that. See, they're supposed to be equal distance. Never mind, because we are just illustrating. Under normal circumstance, there must be same distance from the mirror line to the object, and from the mirror line to the image. The matrix for this mirror line, we have 0, 1, 1, 0. See the difference? The other mirror line, it is when it is at y is equal to -x. You see the difference? Here there was a positive x, now it is -x. It means the mirror line will be in this way. For such questions, for such concepts, it means if the object was to be in this way, just know that the image will be the other way. Same shape, it must be reflected. I didn't draw a good one. Same shape, it will be reflected in the other, on the other side. So mirror line will be in between. For the matrix for this one, as you can see the difference here, you just put negative, negative, since there's also a negative here, right? So this is what you're supposed to do. So these are the concepts that you have to know for you to be able to answer questions under transformation. We continue. Number 3, rotation. In here, on this topic, for rotation, the object will be rotating to form the image. The object will be rotating to form the image. So now, look at this. If you have this, if this is your image, you see, the object can rotate. It can be clockwise direction or anti-clockwise. So let's see how we're able to handle that. So you have to know direction of rotation, angle of rotation, center of rotation. So direction and angle of rotation, we have the positive 90 degrees For this one, the object has to rotate in an anti-clockwise direction. So anti-clockwise, it means this object, if you rotate it like this, this is the anti-clockwise. So this object, it will be like this. You see, it means it has moved in an anti-clockwise direction. This is 90 degrees. Then, and the matrix for this movement is 0, -1, 1, 0. The negative is just on the top, the top number 1. Then, when it is -90 degrees, it means the object will move in a clockwise direction. So here, if this is the object, let it move in a clockwise direction, and we call it -90 degrees. So going this way was +90 degrees. What about going that way? So this object will be like this. You see, it was like this. If it rotates in a clockwise direction, we say it is -90 degrees. So this is the image. So it has moved 90 degrees clockwise direction. The matrix for this one is 0, 1, -1, 0. Have you seen the difference? The negative now is moved to the number down there. The other direction, the other angle and the direction of this rotation, we have 180 degrees rotation. The matrix is -1, 0, 0, -1. You see the difference? Have you seen how the numbers were arranged? This one, the ones are in this way, both carrying a negative. So 180 means, you see the object was here. So if this, it can be 180 degrees, it can be in a clockwise direction or anti-clockwise direction. See? So if this object moved 90 degrees, what about 180? It means it has to come in the straight line with the object. So this one, if it moves, it can maybe look like this. From here, if it moves, it can look like this. So as you can see, it forms straight line, which is the 180 degrees rotation. So to find the center of rotation, join corresponding points. For example, get the A object. When we write A, it means the object, and the second one, it means the image. The object, its image will be A with this prime, right? So bisect, identify the point coming from A point to its image of A, to its image. Connect. When you draw a line, bisect. Remember, under construction, we're able to bisect a line. You also get another one. For example, it depends with the letters given in the shape in that question. So we have B, connect B object and its image, then bisect. Bisect. When you bisect, those two bisectors will meet somewhere. Get the center. Get the center of rotation. It can be 0, 0, it can be 2, 2. It depends with the center of rotation. But do these 2 points. So if under rotation you have been given a question to say, describe this transformation fully, you have to state. If it is rotation, you have to state it is a rotation 90 degrees, for example, anti-clockwise direction with the center maybe 0, 0 or 2, 0 or 3, 0. It means you have described that transformation fully. Number 4, we have enlargement. We are all familiar with this word. So for enlargement, the shape remains the same. If it was a triangle, it will remain the same. The size of the object changes. The shape will change, but the size will change, the shape will remain the same. Now, you have to know that the scale factor K, there's also the center of enlargement. Note, an enlargement is fully defined if the following are stated. You need to state the scale factor, which is K, and the center of enlargement. You have to know. So when they say describe the transformation fully, if it is enlargement, you say it is enlargement, scale factor may be 2, and the center 0, 0. Then you get your 3 marks. Anyway, so for scale factor, this is what you find. This is how to find the scale factor, which is K. You count the units in between, or the length, from the A image to B image. If there are 4 points in between, or 4 units in between, you divide from A to B, the object now. You see, the images on top, from A image to B image. How many units are in between? Are they 4? Are they 5? You just count the steps. Then down there, from A to B, the object now. How many, what's the length from A to B? How many units are there from A to B? You divide. Or maybe it could be B and C. You get the B image, the C image over the B object to C object. You divide. Or maybe the A image to the C image. You divide with the A object to C object. You find the length. You find the scale factor, which is K. So now, there are times also you can use this method for scale factor. You can count from the center. If you know the center of enlargement, you count the units from the center to its image, maybe image A, over from the center to its object, in this case object A. So if you get the A image, get its object as well. Measure the length from the center to the A image, from the center to A object. It could be from the center to B image, over from the center to the B object. It could be from center to C object, over from the center to the C object. You see, center to A image over center to A object. You divide. Still, you'll be able to find the scale factor. So the matrix for the scale factor will be in this way. To be in this way, you have the KK here and the 0 zeros. K represents the scale factor. If it is 2, you put 2, 2. This is the matrix for the enlargement. Then, how do you find the center? For you to know the center, so to find the center of an enlargement, get any 2 corresponding points, e.g., A object to its A image, you draw a dotted line, and B object to its B image, draw another dotted line. So those dotted lines or discontinuous lines will meet somewhere. They will meet, and that is the center. So to find the center of an enlargement, get any 2 corresponding points, e.g., A object to A image, draw another one, B object to B image. Those 2 lines will meet somewhere. Where they will meet, that is the center. It can be 2, 2, 4, 4, 0, 0, or wherever. Note that when the scale factor is greater than 1, the image is greater in size than the object. So when the scale factor k is greater than 1, the image will be bigger in size than the object. Then, when scale factor k is less than 1, the image is smaller in size than the object. Take note. Then, when k, which is the scale factor, is negative, the image and the object are on the opposite of the center of enlargement. So after I've identified the center, and when the k scale factor is negative, you'll find that the object will be on the other side or will be on the opposite with the image. They won't be on the same side. Look at the last point. The last point, when the k is positive, k is the scale factor. When it is positive, the image and the object are on the same side of the center of enlargement. So look out for examples, for more videos on how you'll be able to identify these by taking note of these points so that you can use them when dealing with questions. The fifth transformation is shear. Shear is called elastic transformation. It is like a catapult. What happens when you pull a catapult and you release it? It goes back to its original uh, size. So shear is called elastic transformation. So a shear is completely defined with the following. The shear factor. The shear factor being represented by K. The invariant line. Invariant, it means the line which is not moving. It could be the x-axis or the y-axis. The direction of shear. Is it along x-axis or y-axis? These are the objects which will be transformed, which will be moving. Look at this. Look at this. This is the object. This is the image. So shear will appear like this. This is the object. This is the image. You see shear? It appears to have been pulled, right? It is elastic the way it appears. It appears in an elastic way, as you can see. Look at how it was. Now look at this. Right? So indeed, it is elastic. So now, this is how it is. So in this scenario, this object, if you compare it, which line was not moving? Was it the x-axis or the y-axis? So now, in the next video, we're going to teach you how you're able to identify which line was not moving and which one was moving. So if you compare here, you find that this shape, look at AB, where AB is, and look at where AD is. So indeed, the y-axis was invariant because look at where C is. They got the B and C. It was lifted from here, pulling it to reach there. So the y-axis was untouched. So we call it invariant line. Next, so the matrices for shear, we have 1K, 0, 1, where K represents shear factor, or we can call it the constant. And once the shear factor is on top like this, just know that it was the x-axis which was not moving, or we call it invariant. X-axis was invariant. In the second scenario, the K is down now, the shear factor is down. In this case, it means it was the y-axis which was invariant. Now, shear factor, how do you find the shear factor? For you to find the shear factor, which is K, you get any two corresponding points. Get the A object, for example, to the A image, count how many units are in between. Then divide by, you also count from the invariant line to the A object, or maybe you can get from invariant line to A image, you divide to get the shear factor. Once you get the shear factor, and then they ask you about the matrix, you simply put, if the shear factor is 2, you put 2 where there is K. You put 2 as K. If it is x-axis invariant, you go for this. If it is y-axis invariant, you go for that one. Otherwise, this is how you're supposed to find the shear factor. It's not always to get the A. In case there is a K, or maybe there is a BB, there is letter B on the shape, on the object. So you say from the B object to the B image, you see, it could be from B object to the B image, how many units are in between, you count, over from invariant to B object, from invariant to B object, or you can count the units from invariant to A image. In this case, this y-axis is invariant. It was the one which the shape never moved into that direction or into that direction. So you get any two corresponding points. The A object is here, the A image is here. So from A to A image, how many units? Look, 1 unit, 2 units, 3 units. So you write 3 over, then from invariant line to the A object, or from invariant line to A image. So as you can see, there's just a 1 unit. From this to this, if you count, you check down there, there's just 1 unit. So it will be 3 over 1. So 3 over 1. So here you can say is 3. So K is what? The shear factor could be 3. You see that? The shear factor could be 3. Anyway, let's move on. So next, we have stretch. Stretch is the last part of transformation. So for stretch, it is elastic but does not go back. Remember, under shear, we said shear is elastic. It is like a catapult. It goes back when you pull it. It goes back after releasing it. So you need to know also the direction, which can be along x-axis or y-axis, just like shear. You need also to know invariant line, which can be x-axis or y-axis. In this scenario, remember, this was the object. From this object to this one, it was shear. Shear happened. Shear transformation happened. And from this object to this other one, this was stretch. You see, from this to this, it is stretched. So this object was transformed in this one by shear, and from this to this by stretch. You see that? So stretch is like it's an enlargement as well, right? The object was enlarged, right? So this is how you can differentiate. You see the shear, how it appears? Are you seeing how the stretch appears? Are you seeing the shapes? Are you seeing the original shape, which we call the object? Look at shear, look at stretch. See the difference? In the previous video, we looked at the enlargement. Look at enlargement. From this, it came to this enlargement. From this object, it came to that shear. From this object, it came to that stretch. You see that? So, in this case, have you seen how this shape was stretched? It was stretched like this, in this way. It means it was the y-axis which was not moving. So in this case, the direction of this stretch was x-axis and the invariant line was y-axis, because it never moved towards the y-axis. This shape was not transformed towards the y-axis. So we say y-axis is the invariant line and x-axis was the direction. You see that? So now the matrices are, we have a k on top, 0, 0, and 1. When k is on top like this, which is the stretch factor, y-axis is the one which is invariant. And when the k is down here, it means the x-axis is the one which is the invariant. K represents stretch factor. Now, for you to know the stretch factor, which is k, get any two corresponding images, maybe A image to B image. How many units are in between? If there are 4, you divide by, also count their objects now. From A object to B object, how many units are in between? You divide. It's not always getting AB. There could be AC in that shape, on that shape. So you also get from A image to C image, how many units? You divide from A object to C object, or maybe it could be B image to C image. You divide B object to C object. Then you find the scale factor. So if it is x-axis invariant, you put the number here. If it is 2, 3, or if it is y-axis invariant, you put it there. So when they ask what is the matrix for this stretch, you have to identify, is it on the x-axis or y-axis, so that you know which one to pick. Now, to investigate invariant line, connect these points. For example, A object to B image, draw a line. Also go and connect their images, A image to B image. Where they will meet, that's where, if they meet on the x-axis, it means x-axis was invariant. If they meet on y-axis, it means y-axis was invariant. You can also get any other letters, like AC. From A object to C object, you draw a line. Also from A image to C image, you draw another line. You connect, they will meet somewhere. So look at this. If this is the object, this is stretch, right? It was transformed in this way via stretch. So if you connect from A object to B image, sorry, from A object here, this is A object, B object is here. If you connect, the line can go like this, right? Can go like that. The line can go like that. You also connect the A image and B image. Look at this. Indeed, they will meet somewhere on the y-axis. So this one shows you to say y-axis was your invariant line. This is how you are able to tackle this.